Okay, we finished with chapter 3. Now we're going to move on to chapter 4. Before we do that, I thought we should touch on factoring first. A little recap from Algebra 1 uh, that we're going to be doing. First off, in my whole factoring thing, let's actually talk about three things. And they all have to do with an algebraic term. Well, algebraic terms, right? So the first thing is just what an algebraic term is made up of. Its components. It has three components actually. The first component is what we call a coefficient. You guys have heard these words before. Hopefully I spelled it right. The next component is a variable, the letter beside the coefficient, and the coefficient is the number beside the variable. And the third component is the exponent. So those are three components, and all three of those components make up what we consider an algebraic term, which brings us to what I call nomials. Now, with nomials, I define nomials as just let me bring it down. There we go. And I don't like that color. Terms. Now, other people might define it different ways, but I define a nomial as just a term. It makes it easier to define the other words or the other vocabulary. How? If you have a monomial, really what that is, well, monomials is just one term. One term algebraic expressions, of course. A nomial is an algebraic expression. Monomials just stands for one term. If you're talking about binomials, you're saying two terms. That's what you should be thinking of. And trinomials will say three terms. So examples of monomials, say for example, let's go back to monomials. An example of a monomial will be something like what we just dealt with, 3x squared. Other examples is things like 2x. You can say 4y is a monomial. Those are just one term all put up together. And another one, let's just say 3. Those are all monomials. Binomials have two terms. They're separated by plus and minus signs. So you can say a binomial is something like, I don't know, 2x plus 1 is considered a binomial. Let me make that an example. Other ones are stuff like x squared minus 5x is again a binomial as well. And three terms, an example of a trinomial will be something like x squared minus 5x plus 6. Or something like 2x cubed minus 5x squared plus 3x. Those are all trinomials. Why? Because they have three terms, and each term is separated by a plus and minus sign. So the same way we can say factoring is just breaking down algebraic expressions, we could say that factoring is just breaking down terms. So an example of what I mean is the same one that we had over here. Say if we wanted to break this term down, the term being 3x squared. This can actually be broken down to a 3 and an x squared. Multiply that together, you get back the same thing. However, this x squared can now be broken down into something further, an x and an x. So ultimately, the broken down version of 3x squared is just 3 times x times x. Now notice it's completely factored. We just broke it all the way down. So there will be three types of factoring that I usually deal with, that we'll be dealing with in this class. And here's what I call the first kind common factors, second kind difference of perfect squares, and the third kind trinomials. In this video we'll be dealing with just the first two types of factoring, and then we'll do the trinomial thing in class. Let's go to common factors. Dealing with common factors, you are pretty much just factoring out the greatest common monomial factor, just breaking it down. We can start with 2x plus 6. Hopefully this is all review from Algebra 1. You have 2x plus 6. Let's actually break this down. So the 2x is 2 times x, right? And the 6 breaks down into 2 times 3. So we just broke down both terms of this binomial. We're trying to take a monomial out of that, right? So what I want you to notice is that the terms that they have in common. What they have in common in the terms. Notice they both share a 2, right? So since they both share a 2, I like to do what I call reverse distributing. So you know when you distribute a 2 into something and you multiply by everything inside the parentheses? In this case right here, I'd like to take the 2 out, and basically whatever's left inside is whatever's left inside. So ultimately what I did is I took this 2 and I took that 2 out of the parentheses to end up with, hold on, oh there we go, to end up with the 2 outside here. And what we're left with is an x inside of our parentheses plus 3. And the reason why that works is if I distribute that 2 back in, what I'll be left with if I distribute it back is 2x plus 6, which is what I started out with originally. But what you see in red is the what you see now in red is the completely factored version. I'll do it with this one now. You have let's call this number 2 and let's call this number 1. With x squared plus 3x, if I broke that down, then one part is x squared, not x squared, but x times x plus 3 times x. Now notice what they have in common. They both have an x in common. So just like I did with the last one, I can do it with this one as well. I can take the x out, and once I take the x out, what I have left inside is x plus 3. Now it's fully factored. That's again reverse distributing, where if I distributed that x back in, I'd end up with what I originally had. Here, this is going to take a little bit more breaking down, but we could definitely do this one. Now 4y cubed minus 12y squared plus 24y. First of all, let's break down the 4y cubed. Let's break it down as far as it can go. First, if we break down the 4, that's 2 times y times y times y. Whereas if I multiply all that back together, I would just get my 4y cubed, right? Minus, and since, we'll say minus, and let's break down the 12. If I break down the 12, that breaks down into 2 times 2 times 3 times y, since there's y squared there, right? And if I break down, there's a plus here. If I break down the 24y, that breaks down into 2 times 2 times 2 times 3 times y. So understand how it broke down each one of those. So note, like, now we're going to actually highlight what they have in common. What you'll see is that they each have 2 2's. Each one of them have 2 2's. They have 2 of the 2's in common. Each term does. The next thing that they have in common is, how many y's? I see one y. Notice they each have at least one y. Not any more, not any less than that. They all have a y in common, right? So they have 2's in common, and they have those y's in common. So what happens is we can take all of those, we can reverse distribute that all out of outside of parentheses we're going to make. Okay, I took them all out, and now we just have to notate what we have left. We have a y times y left. We have a minus, we have a 3 times y left. And we have a 2 times 3 left. So if we put all of those back together, you end up with 4y times y squared minus 3y plus 6. So now we can say that that is fully factored. To my knowledge, this is fully factored. So that's pretty much how we do common factors. We'll do more of those in class, but let me talk about the other one that we're going to be dealing with as well. Okay, you guys remember how to FOIL? Going on how to FOIL, remember that's first. That's not how you spell outer. Outer, inner, and last. That just means what we're multiplying the terms by to actually get what we need. So if you're FOILing first, those two right there, that gives you m squared. Your outer, which gives you 2m. Inner, plus 2m. And your last, which is minus 4. Now notice that the middle terms cross out, and we're just left with m squared minus 4. What we're doing is the exact backwards of that. Notice that when I multiply those two things together, I got m squared minus 4. What that means is that m plus 2 times m minus 2, those are factors of m squared minus 4. So if I were to factor m squared minus 4, this would break down to m plus 2 times m minus 2. Which brings us to our second type of factoring, difference of perfect squares, difference of squares, whatever you call it. Now, typically what you remember is that a squared minus b squared just equals a plus b, a minus b. And a and b are just numbers, right? So if I put this in terms that we understand, an example that we have here is x squared minus 4. Notice that's the same exact thing as x squared minus 2 squared, which is the same thing as x plus 2 times x minus 2. It's officially broken out. After a while, this step right here is not going to be necessary. Say, for example, y squared minus 16. Y squared minus 16 just breaks down into y plus 4 times y minus 4. These two things are, that doesn't look like, it looks like an H. Y minus 4. These are factors of y squared minus 16. Understand how we broke that down. Say x squared minus 49 is just x plus 9 times x minus 9. And, well, actually, understand that when we get a little bit more tricky with it, notice these are still perfect squares. That's a perfect square. That's a perfect square. There's a minus sign in between, hence difference of perfect squares. We can break this down as well. 25m squared. If you take 5m and square it, you'll get 25m squared, right? So we'll take 5m here, and we'll take a 5m here. Because if we fold it back together, we get 25m squared. And then 36, break that down, that's going to be a 6 here. It's going to be a 6 here, 1's plus, 1's minus. So really, we're dealing with difference of squares and we're dealing with common factors. Putting those two things together, we can solve problems that look like this. 8 minus 18n squared. First off, you should always try common factors first. So try common factors first. Looking at what they have in common, I'll say they both have a 2 in common. So we can actually take a 2 out. And if I took a 2 out, let's see, that's going to give me a 4 minus 9n squared. These two things are perfect squares. So because those are perfect squares and there's a subtraction sign in between them, we can go a little bit further. That's going to be 2 times 2 minus 3n times 2 plus 3n. Now I know that one was kind of tricky. We'll do more of those in class. As a matter of fact, I'll just stop right here. And I hope this video wasn't too long.